Welcome to episode 103 of your CySA Plus Prepcast. In this episode, we'll explore the Secure Software Development Lifecycle, commonly referred to as the Secure SDLC. As software becomes increasingly integrated into critical business processes, ensuring that applications are secure by design is more than a best practice. It's a necessity. Vulnerabilities introduced during software development can lead to data breaches, operational disruptions, and compliance failures. By embedding security at every stage of the software lifecycle, organizations reduce the likelihood of exploitation, improve code quality, and meet regulatory obligations. Understanding Secure SDLC is essential for cybersecurity professionals, and mastery of this topic will directly support your success on the CySA Plus certification exam. Let's begin by defining what we mean by the Secure Software Development Lifecycle. Secure SDLC is a structured methodology that incorporates security best practices throughout every phase of software development, from initial planning to eventual decommissioning. It ensures that security is not an afterthought, but a foundational element from the beginning. This approach helps reduce technical debt, minimize post-deployment vulnerabilities, and support secure operations throughout the software's entire life. Cybersecurity analysts work closely with developers, project managers, and compliance teams to support the integration of security requirements at each stage. The Secure SDLC begins with the planning phase, where security requirements are identified alongside business requirements. Analysts play a critical role in ensuring that the project scope includes regulatory obligations, data protection needs, and risk mitigation strategies. Threat modeling is often introduced at this stage to anticipate potential attacker tactics and system weaknesses. Secure architecture discussions, access control models, and encryption requirements are all formalized before any code is written. Early integration of security ensures that architectural decisions align with the organization's security goals and avoid costly redesigns later. During the design phase, Secure SDLC practices require development teams to build security into the architecture. Analysts help define secure coding standards, appropriate encryption protocols, identity and access management requirements, and secure communication practices. Design-level controls, such as network segmentation, least privilege principles, and input/output validation mechanisms, are all identified at this stage. The focus is on preventing vulnerabilities through intentional, thoughtful design choices, rather than trying to patch them after the software is built. The development or coding phase is where secure coding practices are put into action. Analysts ensure that developers validate inputs, use parameterized queries, enforce authentication, handle errors securely, and manage sessions with proper expiration and protection techniques. They help ensure that developers avoid common flaws such as buffer overflows, insecure deserialization, or race conditions. Analysts may also contribute by configuring automated tools that perform real-time static code analysis to detect issues early in the development process. Testing is a cornerstone of Secure SDLC. Once code is written, it must be thoroughly tested for security vulnerabilities in addition to functional errors. This includes static application security testing, dynamic application security testing, and manual code reviews. Analysts conduct penetration tests and validate that security controls perform as intended. Testing also includes validation of input handling, access restrictions, encryption effectiveness, and proper error messaging. Identifying vulnerabilities before release significantly reduces the cost of remediation and improves security posture. Modern Secure SDLC workflows incorporate continuous integration and continuous deployment practices. Analysts support these workflows by embedding automated security checks within CI/CD pipelines. These checks include code quality assessments, secret scanning, dependency analysis, and configuration validation. When integrated properly, these tools provide developers with immediate feedback, allowing them to resolve issues before code progresses to later stages. Analysts monitor results, fine-tune detection rules, and work with development teams to prioritize fixes. The deployment phase in Secure SDLC is designed to ensure that newly released software is not only functional but secure. This phase includes enforcing secure configuration baselines, applying final security validations, and verifying that systems are deployed with least privilege principles in place. Analysts validate that secure defaults are used, administrative access is restricted, and all development artifacts, such as debug logs or test data, are removed. Security testing in staging environments is often repeated before final deployment. Once the software is live, the operational phase begins. This phase includes continuous monitoring for vulnerabilities, applying patches, managing configuration changes, and responding to security incidents. Analysts work with IT operations to deploy monitoring tools, collect logs, and set up alerts for abnormal behavior. Secure SDLC requires that systems remain under observation throughout their operational lifespan, and that vulnerabilities discovered post-deployment are addressed promptly through structured vulnerability management processes. Comprehensive documentation is critical at every stage of Secure SDLC. Analysts ensure that security requirements, threat models, secure coding standards, testing procedures, deployment configurations, and incident response steps are documented and updated as the project evolves. Documentation supports compliance audits, knowledge transfer, and post-incident analysis. It also ensures that future development efforts can learn from past experiences, supporting continuous improvement in both security and development practices. For more cyber-related content and books, please check out cyberauthor.me. Also, there are more security courses on cybersecurity and more at baremetalcyber.com. To implement Secure SDLC effectively, organizations must begin by cultivating a security-first culture within development teams. Analysts work with developers, architects, and project managers to ensure that security is viewed as a shared responsibility rather than a barrier to innovation. This culture shift starts with ongoing training, clear documentation of secure coding standards, and leadership support. Developers who understand the risks associated with insecure code are more likely to adopt secure practices voluntarily and raise security concerns during design and implementation. Threat modeling is a vital activity in the early stages of Secure SDLC. Analysts collaborate with development teams to identify potential attack vectors, understand how data flows through the application, and assess the likelihood and impact of different types of threats. Common threat modeling frameworks include STRIDE and PASTA. These models guide teams in asking the right questions about authentication, authorization, data validation, error handling, and trust boundaries. The insights gained from threat modeling directly influence architecture decisions, test planning, and prioritization of security controls. Secure code reviews are essential to identify vulnerabilities before code reaches production. Analysts facilitate regular peer reviews and automated code audits to uncover logic flaws, insecure patterns, or misuse of security libraries. Static analysis tools help identify known vulnerability signatures, while manual reviews catch context-specific issues that tools may miss. Code reviews are integrated into the development pipeline and become a standard part of the definition of done. This proactive step ensures continuous improvement in code quality and reduces the volume of post-deployment issues. Dynamic testing complements static analysis by assessing how the application behaves during execution. Analysts conduct dynamic testing using tools that simulate real-world interactions with the application, often identifying vulnerabilities such as input handling flaws, misconfigurations, or improper session management. Penetration testing provides additional validation, replicating attacker behaviors to test how well the application resists intrusion. These tests are conducted regularly throughout development and again before final deployment, ensuring vulnerabilities are identified from multiple perspectives. Configuration management plays a critical role in the Secure SDLC. Analysts work with DevOps teams to establish and enforce secure baseline configurations across development, staging, and production environments. Configuration checklists ensure consistency in encryption settings, access permissions, logging policies, and software dependencies. Automated deployment tools like Ansible, Chef, or Terraform apply these baselines uniformly, reducing the risk of misconfiguration during infrastructure changes or new deployments. This consistency supports both security and operational stability. Patch management is another critical consideration in Secure SDLC. Analysts ensure that underlying operating systems, libraries, and application frameworks are kept up to date with the latest security patches. Patch schedules are aligned with development sprints or release cycles to maintain secure environments without disrupting delivery timelines. Delays in patching introduce unnecessary risk, so analysts work with operations teams to track vulnerabilities, test patches in staging environments, and apply them during planned maintenance windows. Integrating vulnerability management directly into the development process enhances SDLC security. Analysts incorporate regular scanning into build pipelines using tools that identify outdated libraries, insecure APIs, or known weaknesses in application components. Findings are triaged and assigned severity ratings based on exploitability, business impact, and compliance requirements. Developers and security teams work together to prioritize remediation and confirm fixes before code is promoted. This integration enables near real-time vulnerability detection and reduces time to resolution. Escalation and exception handling processes ensure that vulnerabilities discovered during development are not overlooked. Analysts establish procedures for prioritizing, documenting, and communicating security findings to appropriate stakeholders. Exception processes are in place for scenarios where remediation is not immediately possible. These exceptions are documented, tracked, and periodically reviewed to ensure they do not become persistent risks. Clear escalation paths and accountability structures enable timely decision-making and risk-informed responses. Continuous improvement is a hallmark of effective, secure SDLC implementation. Analysts lead retrospectives following security incidents, failed audits, or significant testing results to evaluate where processes can be strengthened. Lessons learned are used to refine threat models, improve code review checklists, adjust training content, and optimize CI/CD pipeline configurations. Secure SDLC is not static. It adapts based on feedback and experience to meet the organization's evolving threat landscape and business goals. Education remains essential throughout the lifecycle. Analysts ensure that security testing procedures, secure development standards, threat models, deployment plans, and incident response protocols are clearly recorded and version controlled. These artifacts support transparency, audit readiness, and consistent knowledge sharing across development, security, and operations teams. Well-maintained documentation ensures that future projects can reuse proven approaches and avoid repeating past mistakes. To conclude episode 103, the Secure Software Development Lifecycle is a comprehensive framework that ensures security is baked into every stage of application development. By incorporating secure coding practices, proactive threat modeling, robust testing strategies, automated pipeline integrations, and clear escalation procedures, organizations can minimize vulnerabilities and maintain a strong security posture. Cybersecurity analysts are key enablers of this process, helping translate security requirements into technical practices that developers can apply. Mastering secure SDLC strategies not only prepares you for success on the CySA Plus exam, but also positions you to lead secure development efforts in modern, fast-paced environments. Thanks for listening. To learn more about cybersecurity, please visit baremetalcyber.com. There you will find best-selling books, videos, and even more free cybersecurity training courses. Please subscribe to the Prepcast and our various podcasts. And thanks for listening.